Hello guys, welcome to Code Piper. In today's video, we are going to see the efficient ways to do the marshalling and unmarshalling in Go. There are various ways. There are multiple libraries in Go that the Go ecosystem provided to do the marshalling and unmarshalling. So first we understand what is marshalling, and then marshalling and unmarshalling, and then we go further for the testing the different libraries that are provided in the ecosystem. So marshalling is converting your struct or string or whatever data types you have into the byte format, byte array format. And where unmarshalling is kind of opposite of marshalling. So if you have a byte array, you need to convert into some struct. Then you need to do the unmarshalling on that byte array. So let's see in the code, and in this example we are going to see two libraries. One is the JSON, which is inbuilt provided by the Go, and the second one is the Sonic, which is provided by the ByteDance. And we will see by using the benchmark test which one is optimal and which is not. Okay, and also I am quite a fan of Sonic library because it provided some add-ons which is like marshal string or unmarshal string, which is quite helpful when you're doing coding. Let's see. Let me exit it out. And if you see the code, then yeah, so we have this album struct. Okay, so also we have this build response method. What it is doing, it is just taking the input of the size of the array. So any we will provide the size of the array, and it just created an album array. Album is the struct, so t1 is the array. So it just repeat, there is a for loop. We will just append the same array number of times that we provide in the input array, input integer. Okay, so here is the build response method, and here is our marshalling and unmarshalling JSON, and also marshalling and unmarshalling by using Sonic. Okay, now we will go how we are doing the benchmark testing. So we have two methods, benchmark JSON and benchmark Sonic. So we will see one method and its explanation, and other one is much similar to the first one. Okay, so we have this input array. So we will take 10 array of size 10, and then 50, then 100, then 400, and we will see how it performs on different size of input array. Okay, so we if you see, here is the we for loop which is we are doing on the input array. Okay, and we are just building the response. Here we have the album, means array of the album, and in first iteration it will be of size 10, the second iteration it will be of size 50, then 100 and 400. So it is just doing the same operation, marshalling and unmarshalling JSON. And same if you see marshalling and unmarshalling Sonic, we will perform both benchmark and see the result. In this method I will show you what we are doing. So if you see marshalling unmarshalling JSON, so we are just taking input album array. Okay, sorry, input album array, and just doing the marshal first. Here we have the byte response, byte array, and then we are just passing that byte array to form our result, to get the result. Okay, so in this case same is here in Sonic. We just using, here we are using JSON, here we are using Sonic library. If you see, Sonic library is of ByteDance, and JSON is the inbuilt library provided by the Go encoding library. Okay, so I will run first JSON test, and we will see how it is performing. So here are our results. I just copy it down, so it will be helpful later to compare the result. Okay, so JSON one I just copied, and now I will run the Sonic one. Okay, now I am running the Sonic benchmark. We will see how it will perform. So here are our result. I'm just copying it down and paste it in readme. I will provide the link of this GitHub repository in the description section, so you will go later and check what is the code and how we have done this. So just compare. I'm comparing it for the input size 10. If you see number of operations that are performed by Sonic in the same period, it is around 1,84,000. Okay, and here the JSON library performed 21,000, which is much lower to the Sonic one. If you see the operation, it is taking 10,000 something nanosecond per operation. It is on the other hand, it is taking 57,925 nanosecond per operation, which is much higher on the JSON end. Okay, and the same thing here. If you see the memory, it is taking 11 allocations per operation, and where JSON library is taking 57 allocation per second per operation. Sorry, here also per operation. So if you see these metrics on the small input size, clearly Sonic is the winner. For the input size of 50 array, if you see 39,327, here 4,152, here 31,660 nanosecond, or here we are taking around 2,73,000 nanosecond, which is much higher and per operation. Here we are taking 12 allocs, here we are taking 265 allocs per operation. So clearly here also Sonic is the winner in the case when we have the input array of 50. So if you see the input size of 100, here also I can see clearly see Sonic is the winner, obviously, and here also Sonic is the winner. Means in each case, I guess Sonic is performing much better than the JSON library, and the reason for it is clearly the reflection, because JSON library uses reflection to marshal and marshal. Okay, and marshalling, while in marshalling it uses reflection, but in the case of Sonic, it just uses a object pool, which is quite helpful in allocating new memory, and also performing operation without reflection, which is CPU, which doesn't take that much CPU. So yeah, means I would recommend to use Sonic over JSON library. And the operation, if you see the working is quite similar. If you see, if we keep in place of JSON, if you put Sonic, the working is quite similar. Means there is not that much difference. If you see, okay, there's minor differences that you can do, that are doable, I guess. And this is it. I guess this video is helpful for you, and I am making more such videos. To please like, subscribe and share among your friends. Thank you guys.